All right, hey, good afternoon, Algebra 2 Essentials class. Welcome to our first lesson for the term. So we're going to start off here in chapter 1, and we're really going to focus on a concept called sequences. And we're going to talk about different types of sequences, and we're going to talk about this term recursively because it's a way that helps us write sequences. So before we even get to the definition of a sequence, and some of you can probably already read it since I got it on the page, but where do they come about? We can think about this situation, and this is a situation that you probably have heard before back in maybe in the junior highs, or someone proposed this problem to you. So we're going to just kind of start about this think about situation. So it says, suppose someone offered to give you 1 penny on February 1st, and then would then they would give you double the previous day amount each day for the rest of the month. How much do you think you would have by February 28th? Okay? So as we start to think about how this works, okay? On the first day, okay, we have a penny. So this is like day 1. Okay? We get double it. So on day 2, we have 2 cents. So I'm just going to write day 2 here real quick. Day 3, we have 4 cents. Day 4, we have 8 cents. And then we keep on going until we get to day 28. Okay? So notice how I haven't written it because I haven't done all that doubling process. What this pattern is called is we call it a sequence. A sequence is a series, as it says here, a series of numbers that have some sort of mathematical pattern to it. So our pattern here was to get from the first term to the next term, we were simply multiplying by 2 each and every time. So that's our mathematical pattern that's happening. So I know some of you are kind of curious right now, so I'll go to the calculator real quick here. So here's a penny, times it by, whoops, it did take my multiplication. I love it when it does that. My calculator has a habit of doing that. So times it by 2, so there's day 2. Times it by 2, I'm going to use this last answer feature, which can be very helpful early on with these sequences. We'll show you some other technology later lessons that will help even more. So there's day 3. Now if I just hit enter, day 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Wow, day 28. Look at that amount of money. Isn't that crazy? You would have $1,342,177. Excuse me, at 28 cents. That's the amount you get on just that day. That doesn't count all the amounts prior to it, which would actually, for not to go into too detail, which would be this amount minus a penny. Okay? Excuse me. Sorry. Somehow I'm sneezing now. All right, so now the question becomes, how do we go about defining a sequence mathematically? Okay, so notice how I have this kind of like day 1, day 2, dot, 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 and I go all the way to day 28. So what happens is, in mathematics, we like to use shorthand notation. We like to use symbols, don't we? We like to use X, Y, Z, A, B, C, all that fun stuff. You know, Y equals MX plus B, A squared plus B squared equals C squared. Well, we do the same thing for a sequence. So when we talk about sequences here, okay, what we like to do is we like to use this notation, U sub n. Okay, so this U sub n, all it means is U sub n. U subscript, and the n is written as a subscript. Okay. So what it allows us to do is instead of having to write day 1, day 2, day 3, so forth, we could say U sub 1 is the first term, U sub 8 is the 8th term, U sub whatever term I'm looking for, the n is the nth term, whether this is, so if this is a 9, this is the 9th term. If this is 100, this is the 100th term. So what it allows us to do is up here, instead of writing day 1, we could use U sub 1. And this is U sub 2. And this term right here is U sub 28. So now I was just thinking, boy, if this was a leap year, wow, you'd have, $2.6 million, lots of money. Now, how we go about writing this mathematical pattern in an equation is we talk about what we call a recursive formula. So a recursive formula has two parts to it, okay? Recursive formula or recursive rule, two parts. The first part is this right here. So I'm just going to kind of put a 1 here. We always define the first term as U sub 1. Later on, sometimes we'll define it as U sub 0. It all depends on the problem. But in all of these, when we just have a plain list of numbers, we always start with U sub 1 because it's the first term and we define it. So like up here, what we define that first term as 0.01. It was a penny. We started with a penny. Okay? So then the second part always has this part to it. Okay? We define the U sub n to get the next term. It's equal to the previous term, and then we're doing some sort of mathematical operation. We might be adding, subtracting, multiplying, or dividing. Our mathematical operation that we were doing in the previous one, or this problem was, we would say simply multiply by 2. So the recursive definition for this problem right up here would actually look like this. U sub 1, our first term, was a penny. Then to get our next term, U sub n, we take the previous term, U sub n minus 1, and we're timesing it by 2. Okay? And I know this kind of sometimes is U sub n minus 1 and n sometimes confuses students, but if I write this as, if I say I want to find the fifth term, U sub 5, it's equal to U sub 5 minus 1, or the fourth term times 2. So you would like take the fourth term, times it by 2 to get the fifth term. Okay? So it just kind of, it's like a domino effect. You use this formula to always take the previous term, goes into the next term. So the previous domino knocks into the next domino. Okay? All right, so now we get a little more detailed here. And we're going to talk about two specific types of sequences. Okay? The first one here is called an arithmetic sequence. Okay? So I'm going to kind of go neon green here. Hopefully that shows up kind of nice. It's the green, I guess, I have up on my tab. Okay? An arithmetic sequence is a sequence where we add or subtract to get the next term. Notice how I've used adding and subtracting here. Lots of times we like to use the letter D, common difference, to represent what we're either adding or subtracting to get the next term. So what will happen is you'll define the first term. So say if my sequence was something as simple as this. I started and I went 5, 9, 13, 17. Okay? So my first term would be this 5. Okay? So I define U sub 1 as 5. Then notice how to go from next term to next term to next term, I'm adding 4. So the next part I would write would be U sub n equals U sub n minus 1. Notice how that always stays the same. Never changes. Then I go plus 4. Since it was a positive number, whenever d is positive, okay, the sequence increases. It's going up. If you're subtracting, if d is negative, so if instead I kind of flipped this and said 17, 13, 9, 5, instead of going plus 4, I would write minus 4 here, and d would be negative. All right, last example here, geometric sequences. Geometric sequence is a sequence where we multiply or divide. So arithmetic, add, subtract, geometric, multiply or divide. So the letter that we like to use is the letter R for a common ratio, because something is going up by a percentage or going up in essence by some multiple. Okay, so we define this common ratio as R. And R can always be found by taking any next term in the sequence and dividing it by a previous term. So what I mean by that is, like for instance, if I go back to the penny one, I can go anywhere in the sequence. So like if I looked at these two pieces right here, 8 cents versus 4 cents. This is the next term, this was the previous term. So if I divide, if I go that next term, which was 8 cents, divided by 4 cents, I get simply 2. That's what I was multiplying by. Okay? So what you'll notice is, like if I'm writing the one up top, just like we said, u sub 1, the first term, was a penny. Then I'd say u sub n equals u sub n minus 1. Sorry, the equal didn't go nicely there. And I'd simply say multiply by 2. So what happens is, when r is greater than 1, your geometric sequence is going to increase, meaning the numbers are going to get bigger, bigger, bigger. Okay? So when we think about increasing, think about the values getting bigger. Okay? When it's decreasing, think about the numbers getting smaller. Okay? Or they could, like with difference, they'll actually become more negative. Okay? All right, so now in the note packet, if you actually download it or are looking at it as you're watching this notes, there's a space at the bottom, but these might be some good example problems, maybe to even put in a notebook. Okay, so as you're taking, if you're taking notes either on the note packet, if you print it out or whatnot. If you don't have the note packet, I get it. Again, the notebook I think is just going to be huge for this class. Okay, so I just want to go through some examples like this here, and these will help you when you do your worksheet problem. So here are 3 examples where I have a sequence. I need to determine if it's arithmetic or geometric, if it's increasing or decreasing, and the D, the common difference, or the R value. Now think about this, okay? I'm just going to kind of note something here. Arithmetic and the letter D go hand in hand. Geometric and R go hand in hand, okay? Don't crisscross those, okay? As much as you, if you can. Some people help them by remembering this little phrase or 4-letter acronym, GRAD, geometric ratio, arithmetic difference, okay? Because you're going to be a high school grad someday. All right, so let's take a look at the first one. So when I look at this, I try to look at, all right, am I adding the same value to get the next number? And if I'm not adding or subtracting, then I know it's got to be geometric, and I'll use this little handy-dandy formula to figure out the pattern. So when I look at this one, right away I'm thinking, oh, 8 plus 8 is 16, plus another 8 is 24, so it seems to be holding that pattern, so this tells me it's arithmetic. Since the values are going up, I know it's increasing, okay? And not only that, since I know it's arithmetic, D, the common difference is a positive 8. Now, do you have to have the plus sign? No, but I'll tell you right now, it does help a little bit, because one of the things that I'm not asking you to do on this particular problem, but I'm just going to do it here in the notes because it might come up in the worksheet, is what's the recursive formula? So u sub 1 is the first term, 8. and then u sub n equals u sub n minus 1. And then, what am I doing? Well, I'm adding, what's the mathematical operation? I'm adding 8 to get the next term. All right, first one down. Second one, if I look at this one, 100 to 91, 91 to 82, 82 to 93. Well, it looks like I am subtracting 9 each and every time. So this one is still arithmetic, but this one is decreasing, okay? And so it's still D, and it's very important to put the minus 9, because I'm subtracting 9 each and every time. So if I were to ask you to write the recursive definition, u sub 1, that's the first term, 100. The second part, this is always the same. I always just write this, u sub n equals u sub n minus 1. Now I just got to figure out the mathematical operation, which is nice defining it here. I just go minus 9. It's hopefully that easy. Okay? All right, the next one. All right, I know it's in a darker green here. I am not going to use that darker, or this neon green. I think it's probably hard to see. So let's see, I could probably use, well, let's see here. I got purple, so I'll use this light blue. All right, so when I look at this one, 2, 4, 8, 16, 32, I think we kind of saw that pattern with the pennies, okay? Because if I go 2 plus 2, I get 4, but 4 plus 2 is not 8. So I know that it's, okay, geometric. I already know it. Since it's not arithmetic, must be geometric. So now, to figure out R, simply take the next term and divide it by the previous term. Now, some of you probably already saw that it's going to be 2. Sometimes they're obvious, but when we get to the next one, not so obvious. Okay? But we know it's geometric. We know it's going up, so we know it's increasing. So now, I'm just going to go right, whoops. We define R as what we're multiplying by. So we're timesing it by 2. So now to write the recursive, u sub 1 equals the first term, 2. Then u sub n equals u sub n minus 1 happens to be the same number 2. That was kind of interesting that happened on both those examples. All right, last one. Okay, 100 to 90. Well, that'd be like minusing 10. 90 minus 10 is 80. Well, it says 81, so I know it's not arithmetic, so it has to be geometric. I also see that it is going down, so I know it's, whoops, I just wrote increasing. Disturbed parts. First mistake of the year. How about that? It's actually decreasing. At least I caught it. Okay? So now I got to figure out what R is. Okay? This is where that next divided by, okay, divided by previous gives it to you. So 90 divided by 100 is 0.9. Now you might be going, well, how do I know that that's right? Let's use our technology just to double check it. So one of the things I can do is come here and start at 100 and say, all right, 100 times this ratio of 0.9. 90. I go times 0.9 again to check the next term. Ooh, it is 81. Hit again one more time, 72.9. Everything is matching. That's beautiful. So now, as I write the recursive, u sub 1 equals, so now my first term is 100. U sub n equals u sub n minus 1. And then I write the operation times 0.9. So you're going to see with geometric, I'm always going to get R to be a ratio, and I'm always going to use multiplying. I know technically we could say division, and we could say divided by, you know, in this case, actually we would like be, you know, instead of multiplying by 0.9, you're dividing it. And so I think it's just much easier to convert it to a multiplication problem. All right, so we got one more page with just a couple more examples. Right? So if I look at this particular one here, it says, in this example, write the recursive rule to produce the numbers in this chart. So here, if I think about this, how this is set up, okay, the 1, 2, 3, 4, all the way to 10, this is the term, okay, and down here is the sequence. It's not my favorite way. I usually will just give you the sequence to figure it out. So in this case, though, however, what's nice is you could say u sub 1 equals 8. The first term was 8. So now I'm going from 8 to 2 to negative 4 to negative 10. Wow. So now I can start by saying u sub n equals u sub n minus 1. Now I got to figure out, all right, is this arithmetic or geometric? So to go from 8 to 2, logic says, well, I subtract 6. If I subtract 6 again, do I get negative 4? If you're not convinced, go 8 minus 6. Use your technology, minus 6 again. Ooh, minus 6 again. Look at that, they're starting to match up. So I know that here, the mathematical operation is minus 6. Now, just for fun, we're going to find this term, since it's blank. Okay? If you're asked to find a particular term, I'm trying to find u sub 10. So this is where the calculator helps a ton. Because if you look at how I'm set up here on the calculator, okay, here was my second term. So my first term was 8. My second term is 2. Third term, fourth term. Since I have this plugged in, there's my 5th, 6th, 7th, 8th, 9th, 10th. So my 10th term is minus 46. Otherwise, we could say that u sub 10 is negative 46. All right, second problem here, and this is actually the last one we're going to do for the lesson today, okay, is we'll look at this one. So if I look, here is my first term defined. So to actually, instead of using u sub 1, we actually say u sub 0 is 400. So we're going to have problems later on where instead of saying after the first day or the, whatnot, it might be we start with 400 and then after 1 year we're at 160 and the second year we're only at 64. So that's where u sub 0 comes into play, and we'll talk a lot about that in 1.2. Okay? So now, 400 to 160, we lost 240. If I were to subtract 240 again, I don't get 64. So this tells me right away it's not arithmetic, it's geometric. So I'm going to use that R and see if that works. 160, and I'm going to divide it by 400. So yeah, let's use our calculator. 160 divided by 400 is 0.4. So let's see, if I multiply by 0.4, am I getting the next term each and every time? So that's fine. 400 times 0.4 does give me 160 times 0.4. Okay, whoops. I'm going to start over there for a second. Sometimes it does that to me. It drives me crazy. So you'll see that a little bit in my notes. 160 times 0.4, okay, 64, so that's matching up, times 0.4, so I could have actually hit enter again. So I'm starting to match up here. So I can write my u sub n equals u sub n minus 1. I simply write the mathematical operation times 0.4. So to find the 10th term, remember how this started, 400 was actually 0. So that's the thing we got to be careful. This was the 0 term. First term, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. Wow, tiny, 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 0.04, and I'll just go 19. Just keep it as that. All right, so we are not going to do example number 3. It's actually kind of, if you want to look at it, you'll see it's a really bad Valentine's gift to give to your loved one. All right, that takes care of the notes for today. Go ahead and try the assignment for this lesson, assignment 1.1 worksheet. And If you're having troubles, watch the video to help you through the assignment. Have a great day. Let me know if you have any questions.